Next, I'd like to welcome Luc LePottier to share about his work with Atlas and his data analysis.
Yeah, thank you so much. Let me pull up my slides. Cool. Is that visible? Can you thumbs up maybe?
Looks great.
Cool. Awesome. Yeah, so my name is Luc LePottier. I'm a fifth year senior in the physics department, and I'm going to go to grad school in physics at Berkeley next year. So I'll sadly be done with Atlas. But at AI, I work as a data science fellow, working mostly on the Atlas course utility. So today I'm going to be talking about kind of the correlations, or not really correlations, but just the similarities between student outcomes and Atlas usage broadly. I'll start just by talking about some Atlas usage. So these are just like overall statistics broken down by LARC demographics. So to start, this is just a plot showing the percentage of the first year undergrads for the 2019 class using Atlas each day. So, you know, a spike of like 10% would mean that 10% of the total student body of this freshman class used Atlas in whatever the week this was. And so this is kind of an interesting plot because you can see some pretty clear features. In particular, you can see like weekly spikes where there's about 2 to 3% on any given time using Atlas in each of those times. A dead period near August because the students aren't actually in school yet. And then over the course of the semester, you can see different features like the first week of school here, and then registration and backpacking around here. So this just gives us a feel for like overall what a semester of Atlas usage would look like, and some of the like features that would be there. Then we can break it down by basically different demographics. So the LARC database, which I'm sure some people are familiar with, but I'll explain, basically assigns like categorical demographics. So these are just basically breakdowns of those demographics. So the top plot here is first generation in purple, underrepresented minority, which is a LARC flag in red, and neither of those, and not international. I know that's a little bit confusing, in blue, with the counts for each. And so here, instead of plotting usage each day, this is cumulative daily usage. So the percentage of the entire body of students in that category that has used Atlas. So we can see over the course of one semester from May 2019 to January 2020 for the 2019 class, that on average, the non-URM and non-first gen students are using at a higher rate. So about 80% at the end of the semester, as opposed to, I think this is about 5% less, so 70 to 75% for the other demographics. Though it seems to be that they're catching up over the course of the semester. So like the first generation gap between non-URM, non-first gen is narrowing over the course of the semester. You can also see these features that we were talking about before, which I think roughly correspond to orientations, though, you know, this is all just pointing out different dates and none of it's causative, obviously. But yeah, this kind of creates like this step function, which is interesting to see. The second plot shows domestic students total. So this is actually the entire first plot combined versus international students, which for here was a fairly small subset. But you can see that there's like this there's one day basically right at the end of August where all the international students started using Atlas, and the trend is about 5% higher for the rest of the category. It was mentioned to me that this is likely due to a one-day orientation process or something like this. But so yeah, that's kind of the usage statistics for just one year of undergraduates overall. Next, I'm going to show, so this is kind of an interesting plot. This is basically frequency of unique visits. So this is the days. So if you look at that last plot, this is the number of days total that each user visited Atlas. So you can kind of see the frequency. So for most groups, the majority is 0 to 1 days, where that was the like basically mode that they visited Atlas in over that entire course of a full semester period. But it's kind of interesting to see how these fall out. So first of all, there's kind of like you can see that there's differences in the number of users that are like barely using Atlas at all. And then again, there's pretty significant differences in the people that use it really quite a lot. So some quick statistics, because this is kind of hard to look at just on the fly, but quick statistics about these people, which we were kind of categorizing as people that really use Atlas a lot. So that's greater than 32 visit days in a 370-day semester, but really it's less because that's counting from May all the way to January. 70% are male from the large statistics. 91% are international students, again from the large statistics, and 90% are majority or continuing generation. So, and then for the 15% are in the business school, whereas that's 7% of the total students. So it's like twice the representation than you'd expect. So yeah, I'll keep moving just to keep things going. Okay, so now we're going to talk about course outcomes, which is the other part that I wanted to talk about. And this kind of follows naturally from looking at demographics or usage demographic like correlations. Is looking at like how does that translate to like grade in the course. And here we're generally talking about grade or grade converted to GPA in the course. So the most basic way to separate users into usage categories is like binary. So for a given class, did that student look at the class on Atlas at any time, or did they never do that? So even with these kind of basic categories, there's some evident differences. I'll show first just one way of visualizing these. This is not the like most data rich way, or it's just a good way to visualize the differences between them, because in general we find differences. These are going to be violin plots of GPA converted grade distributions with medians 25th and 75th percentiles shown and the means shown as white dots. Also for this, we compressed the A or higher and C or lower grades into simple groups. So A and A plus is not differentiated. And anything lower than a C is not differentiated, because this helps a lot with like statistical I guess, estimations. So for each of these violin plots, each one is a course, or each one is a field, actually. So we grouped together all the courses in this field that were 200 and 300 level courses, or 100 through 300 level courses. The blue plot is the people that didn't use Atlas, and the red is the people that did use Atlas. So you can see that in some of the fields, it's not a significant difference. In some, like math, the distribution is pretty heavily skewed towards the higher grades for people using Atlas and the lower for people not using Atlas. So this is kind of a nice way of visualizing that with like higher statistics than using single courses, just combining across categories. But also important to note that, especially for something like English, field distributions are completely dominated in some cases by the largest course in that field. So actually stats is not on here, but that would be another one where stats 250 dominates. But in general, I mean, you see that there's a higher mean GPA, and well, the median is like binned by the GPA, so it's often the same. But there's different statistics for Atlas users, and this is something that we've seen before, but it's a different way of visualizing it. This is the same thing, but for the 8 largest classes taken by first-year undergrads. So again, you see kind of the same thing across these courses, with a little bit less of a difference in something like English 125, as you see the grade distribution is somewhat more compressed towards the A side in the first place. So once we did this, we kind of came up with some more specific categories. So this was a 4-category breakdown. We actually tried a even more refined breakdown, but it wasn't super effective. It was difficult to find differences because of low statistics. We broke it up into 4 categories: people that didn't use Atlas at all, people that used it before the start of the term, people that used it after the start of the term, and this is all for a given class, and people that used Atlas in both periods. Then we kind of architected this bootstrapping method to compare differences between users across all of LSA and engineering. And I won't go, I can explain, I guess, in detail if there's any interest later, but I won't go into detail exactly on how we did that. But that basically allows us to estimate the mean and the uncertainty on the mean of basically if people got A, B, or C grades across all the courses in LSA. So we can see basically the differences between these 4 usage categories across the entire school. And so these are just the counts, and I have all the numbers here, but obviously don't take a look at these unless you're really interested. So I'll move on to the normalized plots because it's more difficult to read these since the categories are different size. So this is the fraction of the category that received that grade. So if you look at like all the black bars should sum to 1 because it's a fractional amount. And you can see that in general, and this is the error, it's 2.5 to 97.5. So this is actually a very tight error bound. But in general, the before start in both categories are significantly above the no Atlas categories. And this is for all courses with total enrollment greater than 300 in fall 2019, winter 2019, which is 142 total courses. I know that's very wordy, but so yeah, basically you see that there's these two categories, the before start and both categories are somewhat significantly above Atlas, especially given that these error bars are very strict, basically. You can also see that people that used Atlas after the start have less of, I guess, a boosted A category band. Just another interesting thing to see. And if people are interested in looking at the exact numbers, they're all down here. So yeah, that's actually all I had to present. But if people have questions on the statistical calculations exactly, I can definitely go into detail later. But yeah, thank you.